Hey guys, we're on our next math lesson, and hopefully everybody practiced with volume yesterday. So today we're going to go ahead and work on area. So I know it seems backwards, but we're going back and forth. The reason we're doing area now is because we're practicing it with fractions again. So we've done area with whole numbers a lot, and we want to take a look at what it looks like with fractions. So then eventually we're going to get back into volume with fractions as well. But area is a simpler place to start. So what I want to do today is actually work with you just on a piece of paper, blank piece of paper, not your workbook page yet. We're going to start with a blank piece of paper and just practice what this looks like just to remember. So make sure you have something to write on to practice with me just like you would in class. Whiteboard, paper, anything, right? Okay, so let's practice just what area is. Think about that. Area is the space inside, and it's the space inside a flat surface. So we're not talking three-dimensional. We're talking like if we are looking at, oh, and you know this is going to be a bad drawing on the computer, but we're looking at a rectangle, right? Okay, could be a rectangle, could be a square. We can find area of triangles and things like that, but we're focusing mostly on rectangles right now, okay? So if they give us what we might call the width and what we might call the length, okay, of a rectangle, can we find the area? Hopefully your answer is yes. Remember, area, our equation, area equals what? Good, area equals length times width, right? So if I have the length and I call the length 1/3, and I have the width and I call the width 2/9, or I can switch them around, okay? It doesn't really matter. Remember, when we multiply, we can put them in any order, so however you label it, okay? Then to find the area of this rectangle, I need to do area equals 1/3 times 2/9. If you wrote 2/9 times 1/3, that's great too, okay? So then all I'm doing is multiplying my fractions. Who remembers multiplying fractions? Do I have to have a common denominator to multiply a fraction? And the answer is no. Nope, we don't need a common denominator to multiply. Remember, we only have to have a common denominator to add and subtract. So multiplying fractions is easier than adding and subtracting, right? So all I have to do is say, okay, I can multiply my numerators. So I have 1 times 2 equals 2. And then I can multiply my denominators, and 3 times 9, well, I'm going to think about my 9s trick if I'm not sure, counting by 9s, 9, 18, 27. So I have an area of 2/27. I didn't give this a label specifically, so I'm just going to say U for units. And area, how many numbers do we multiply together? 2, right? So units, and I have a teeny tiny 2 for squared, okay? 2/27. Can I make this any simpler? Is there anything that goes into both 2 and 27? Nope, I have an even 2 and an odd 27. Nothing goes into both, so that is as simplified as it is. That is our best answer, right? So let's try another one. I want you drawing now. So draw another rectangle. Doesn't have to be perfect. You know mine aren't. That's better, though. I'm getting better on the computer. Okay, and let's do 2/3. And this length here is 3/4. Okay? So I'm going to set up my equation, and I know area equals length times width, right? You can pause anytime you need to catch up with your drawing and then just start again, right? So area equals, let's go ahead and start with this as the length. So we're going to say 3/4, and we're going to say times 2/3. If you did 2/3 times 3/4, is that okay? Absolutely. Oh, pop-ups. Hate that. Okay. All right. So I'm going to look and I'm going to say, okay, is there anything that I can simplify before I multiply using that butterfly, right? If there's something I can make simpler first, let's do it. These numbers are not hard to multiply, but when we get into those big ones, sometimes it's really valuable. So I'm going to look this way. I'm going to go, okay, so cross-canceling. I have 2 and 4. Do they have something in common? Yeah, I can divide them both by 2, right? So 2 divided by 2 equals 1. So this becomes 1. And 4 divided by 2 equals 2. So now that's a 2. Can I still use a butterfly, or am I just stuck with this one little caterpillar here? Well, let's take a look. This way, if I cross cancel, I have 3 and 3. Well, they're both divisible by what? By 3, obviously, okay? So I'm dividing by 3. So 3 divided by 3 is 1, and 3 divided by 3 is 1. So now all I'm multiplying is 1 times 1 equals 1, and 2 times 1 equals 2. So the area of this rectangle is 1/2 units what? Squared, right? Okay. Simple enough when we're doing just our regular fractions, right? Okay, so I'm going to show you one more, and I want you to just practice, and I'm going to give you a minute to do it. So let's do just a regular practice again. Here's a rectangle, and we have, let's do 5/8 and 4/10, and I want you to set up your equation, okay? Area equals length times width, and I'm going to give you a minute. You can pause if you want to set it up and solve. Okay, so you probably need a little bit of time still, but I'm going to go ahead and write in my part 5/8 times 4/10. Hopefully you paused so you can work. And I'm going to think about, can I cross cancel? Can I simplify using my butterfly? And I have right here a 4 and an 8, and I know they have something in common. And I have 5 and 10, and I know they have something in common. So it looks like I can both ways again. So 4 and 8, what goes into both 4 and 8? Yeah, you're right, 2 goes into both of them. But is there something bigger? 4, right? So 4 divided by 4 equals 1. 8 divided by 4 equals 2. Is there something that goes both into 5 and 10? 5, right? Okay, 5 divided by 5 equals 1. 10 divided by 5 equals 2. So now I have an equation that is very simple. 1 times 1 equals 1. 2 times 2 equals 4. So now I have 1/4 units. What's your label? Area means squared, right? Okay, so those are easy. Those are basic review. We're going to go over something that's a little bit trickier that's going to be on some of your math today, okay? So when you do that, I'm going to say, make sure you're thinking about going mad. Yes, mad. Be really mad, right? Okay, so who remembers mad? Okay, when I have a mixed number, I want to go mad. And mad means first I multiply, then I add, and then I leave the denominator the same. I don't change my denominator, okay? So mad, multiply, add, denominator. Say it, mad, multiply, add, denominator. Okay, so here we go. We're going to practice one, and it's going to be the same thing whether we have the rectangle drawn or not. We're going to practice one just without the rectangle for right now. So let's do this one. Let's do 5 and 2/3. Remember, it's a mixed number because we have a whole number and a fraction, times 2 and 1/3. Okay, this is not as easy because we've got these whole numbers in here. And the best way to solve this problem is to get rid of the whole numbers and make them into an improper fraction. Who remembers what an improper fraction is? Okay, hopefully you said that an improper fraction has a number in the numerator up top that is bigger than the denominator, right? So we're going to go mad and make them improper now, right? We did this in class. So we go like this. First thing we do is multiply. This is my m, okay? We're going to multiply my denominator times my whole number. So 5 times 3 equals 15. The next thing we're going to do is add. There's my add for mad. Okay, that's my A. So 15 plus 2 equals, good, 17. So I'm going to write 17 right here. And the last thing we do is keep our denominator the same. So now I have 17/3. 5 and 2/3 is the same thing as 17/3. Okay, now we have to get mad at the other one, all right? Mixed numbers make me mad, so I'm going to make them into improper fractions. So the first thing I do is multiply, right? So here I'm going to put a times sign this time, multiplication sign. And so I have 3 times 2 equals 6. Now I have to do what? Add. 6 plus 1 equals 7. So I'm going to add those together, and I keep my D for mad is denominator. Keep it the same. My sign does not change. I'm still multiplying these two fractions. But now I have two regular fractions, not mixed numbers, okay, even though they are improper. So now I'm going to say, okay, can I multiply? Sure. Is there anything I can simplify? Does 3 go into 7? Not evenly. Does 3 go into 17? Not evenly. Oh, that's a bummer. Okay, I would like to make this simpler, but I can't. So I have to multiply across. I'm going to start with the bottom one because it's easy. 3 times 3 equals, 9. Okay, now I have to do 17 times 7. And I'm not really good at 17s. I don't know my 17 multiples. So I'm going to set up an equation. And I'm going to stack them because it's always easier. So I'm going to do 17. I'm going to do 17 times 7. So I'm going to start 7 times 7 equals, should know that one, it's 49. So I'm going to carry my 4 over here. 7 times 1 equals 7 plus 4 more equals 11. So here I have 119 ninths. That's a pretty big number, isn't it? All right, so what normally we would do is try and simplify that. If you can get this far, woohoo, give yourself a pat on the back, good job. Okay, that's awesome because going mad on a fraction is tough, all right? But we want to actually simplify this as well. So if we can get this down to the lowest possible number that we can make it into, we're gonna be good. So remember, my numerator is bigger than my denominator. It's improper. So what do I do to it? I have to divide, right? So I have 119 divided by 9. Remember, my fraction bar is just a division symbol. Okay, so can 9 go into 1? Nope. Can 9 go into 11? So we're going to draw a line here. 9 goes into 11 how many times? 1 time. 1 times 9 equals 9. So let's get rid of that. We used up 9 of them. Subtract. What's left? 2, right? Well, 9 can't go into 2, so we kind of bring that over and we make it 29, right? How many times does 9 go into 29? Well, let's count. 9, 18, 27. Oh, I don't think I'm going to get any closer. So 3 times. 9 times 3 equals 27. And I subtract that away, so what's left? Oh, 2. Well, 9 can't go into 2, so that's a remainder. That's what's left over, but we're using a fraction. So do we say remainder? Nope, we don't say remainder. We say we have 2 left over out of, what was our divisor? 9. So our answer completed is 13 2/9. Okay? All right, and then we're talking about, if we're talking about area, if we drew this as a rectangle and these were our sides, we would still have to have units squared, but we didn't put it in a rectangle this time. So that's the end of this video for practice. I'm going to get on the next video and show you a little bit about what you're doing on the actual math page that you've been assigned for Wednesday. All right, guys, keep practicing. We've got this. This is stuff we've done before. You can do it, okay? All right, talk to you later.